Hello. Good day everyone. This is your teacher in CSS subject, Teacher Jinky. Today, we are going to learn the third learning outcome, in applying quality standards common competency, which is, LO3, engage in quality improvement. Today's discussion is all about quality management. But before we start, let us know the learning objectives that are set for you to learn as you go along the presentation. At the end of this module, the learner shall be able to apply quality standards in computer systems servicing. Participate process improvement procedures in relative to workplace assignment. Carry out work in accordance with process improvement procedures, and monitor performance of operation, or quality of product of service, to ensure customer satisfaction.
Quality management. It is the act of overseeing all activities and tasks needed to maintain a desired level of excellence. Quality management includes the determination of a quality policy, creating and implementing quality planning and assurance, and quality control and quality improvement. Quality management is focused not only on product and service quality, but also on the means to achieve it. Quality management, therefore, uses quality assurance and control of processes as well as products to achieve more consistent quality.
There are 4 components of quality management. These are quality planning, quality assurance, quality control, and quality improvement.
Let's go first with quality planning. Quality planning, or QP, refers to the process of identifying which quality standards to focus on, and then determine what to do. Quality planning means planning how to fulfill process and product deliverable quality requirements. Quality is the degree to which a set of inherent characteristics fulfill requirements. Second is the quality assurance. Quality assurance, or QA, is a program for the systematic monitoring of different aspects of production. We also use QA for projects and services. QC occurs after the finished product is completed, while QA happens before. Third is the quality control. Quality control, or QC, is a system in manufacturing for maintaining standards. Inspectors examine the final product to make sure it meets standards and specifications. When the company provides a service, the inspector checks the end results. And the last one is quality improvement. Quality improvement, or QI, focuses on improving the production process. However, the target could be any part of an organization. One vital ingredient in successful and sustained improvement is how changes are introduced and implemented. So, these are the 4 components of quality management. In technical usage, quality can have 2 meanings. It could mean that the characteristics of a product or service that bear on its ability to satisfy stated or implied needs. And also, it could be a product or service that is free of deficiencies. Quality has no specific meaning, unless related to a specific function and/or object. Quality is a perceptual, conditional, and somewhat subjective attribute. Let us talk about quality improvement processes. Manufacturers can choose from a variety of tools to improve their quality processes. The trick is to know which tools to use for each situation, and increasing the sophistication of the tools in the repertoire. The following are the tools that you can use to improve quality processes. The first quality improvement process is the 6-step profit model, in which the acronym stands for P for problem definition, R for root cause identification and analysis, O for optimal solution, based on root causes, F for finalize, how the corrective action will be implemented, I for implement the plan, and T for track the effectiveness of the implementation and verify that the desired results are met. If the desired results are not met, the cycle is repeated. Another popular quality improvement process is the Plan, Do, Check, Act, or PDCA cycle. This is the most common process for quality improvement. The cycle promotes continuous improvement and should be thought of as a spiral, not a circle. Both the PDCA and the profit models can be used for problem solving, as well as for continuous quality improvement. In companies that follow total quality principles, whichever model is chosen should be used consistently in every department or function in which quality improvement teams are working. Next is the flowchart. Flowchart describes a process in as much detail as possible by graphically displaying the steps in proper sequence. The photo shown is a simple flowchart on using taps. A good flowchart should show all process steps under analysis by the quality improvement team, identify critical process points for control, suggest areas for further improvement, and help explain and solve a problem. Next is check sheets. Check sheets help organize data by category. It clearly organizes data. A check sheet is the easiest way to track information. It also shows how many times each particular value occurs, and their information is increasingly helpful as more data are collected. The figure shown shows a check sheet used to collect data on telephone interruptions. The tick marks were added as data was collected over several weeks. Next is Pareto diagram. The Pareto diagram is named after Vilfredo Pareto, a 19th-century Italian economist. The Pareto analysis technique is used primarily to identify and evaluate nonconformities, and it can summarize all types of data. A Pareto diagram puts data in a hierarchical order, figure 4, which allows the most significant problems to be corrected first. It is perhaps the diagram most often used in management presentations. Next is cause and effect diagram. The cause and effect diagram is sometimes called an Ishikawa diagram, after its inventor. It is also known as a fishbone diagram, because of its shape. A cause and effect diagram describes a relationship between variables. The undesirable outcome is shown as effect, and related causes are shown leading to the said effect. This popular tool has one severe limitation, however, in that users can overlook important, complex interactions between causes. Thus, if a problem is caused by a combination of factors, it is difficult to use this tool to depict and solve it. Histogram. The histogram plots data in a frequency distribution table. A histogram is an easy way to see the distribution of the data, its average, and variability. What distinguishes the histogram from a check sheet is that its data are grouped into rows, so that the identity of individual values is lost. Scatter diagrams. The scatter diagram graphs pairs of numerical data, with one variable on each axis, to look for a relationship between them. If the variables are correlated, the points will fall along a line or curve. The better the correlation, the tighter the points will hug the line. The plotted data points, in a scatter diagram, show the relationship between two variables. And lastly, control charts. A control chart displays statistically determined upper and lower limits, drawn on either side of a process average. This chart shows if the collected data are within upper and lower limits previously determined, through statistical calculations of raw data from earlier trials. And that will be all for the Week 3 discussion. Always remember this saying by Frank A. Clark: criticism, like rain, should be gentle enough to nourish a man's growth without destroying his roots. Again, this is Teacher Jinky, your CSS teacher. Goodbye.